Hi, my name's David, and today we're going to do another pair programming LeetCode problem. I know that studying for coding interviews can be tough and frustrating. So with this video series, I hope that to show that it can be fun and exciting. Today we have our special guest, Ezekiel. Ezekiel, thank you for coming. Why don't you introduce yourself?
Yeah, thanks, David. So I'm Ezekiel. I'm located in the Tampa Bay, Florida area, and currently I'm a software engineering apprentice.
Awesome and fun question. What country would you like to visit next?
Yeah, so I think the next country I plan to visit is probably Italy. Really nice area
Awesome.
to visit.
All right, why don't you share your screen?
Yeah, cool.
And today you'll be using Java, right?
Yeah, so today I'm going to use Java.
Great. So today we're going to be doing number 1790, check if one string swap can make strings equal. Take your time, read the prompt, make sure you understand it, and then explain back to us your understanding of how the examples work. Once you understand the prompt, you may begin coding. And once we get a solution, we'll go over it and talk about the time and space complexity. You may begin.
Well, thanks, David. So this is 1790. Check if one string swap can make strings equal. If you're given two strings S and S1 and S2 of equal length, a string swap is an operation where you choose two indices in a string, not necessarily different, and swap the characters at these indices. Return true if it is possible to make both strings equal by performing at most one string swap on exactly one of the strings. Otherwise, return false. So example one, we have bank, and then we have can. And to swap that, we would do one swap with the B and one swap with the K, and that would give us bank for both strings. Cool. Cool. And it does mention that they don't necessarily have to be the same index.
So why don't you explain example 2 and 3?
Yeah, so example 2, we have attack and defend, right? These are two very different words. And there's no swap that we could make to make these strings equal each other, right? And then if we take a look at the last example, kelb, those are already the exact same. So it's true because we need to make 0 swaps.
Okay. Do you mind summarizing again what makes it return true and what makes it return false?
Yeah, so our goal is essentially to make the two strings equal with one or less swaps. And it must be done on the same string, right? So you can't swap like index 1 on string 1 and then index 3 on string 2, right? The swaps have to be done on the exact same string.
Got it.
Cool.
So it looks like you understand. So how do you think you can solve this?
Yeah. So if we look at the constraints, the length are always going to be the same. Length for either one is going to be 1 to 100, and S1 and S2 consist of only English letters. Okay. Cool. So
and also if you need to look up any syntax, you're able to do so.
Okay. Cool. That's interesting. So we essentially want to so this is an interesting one because we don't know necessarily which string we want to make the swap for, if that makes sense. Right, so like in the case of example 1, right, string 2 could be bank and this one could be the incorrect one. So we don't necessarily know which string we need to make the swap for, but I guess that's not an issue because we could technically make a swap from the B to the K on S1, and that would give us that would make them equal as well.
Right, it should be the same.
Yeah.
One swap from either strings.
Yeah, so I think in that case, we could probably just pick one of the strings and try to match it to the other one, because it doesn't really matter which string we try to match it to, right? No matter what, if they are equal, if it does end up being possible, then it doesn't matter whether we swap K and B on S2, or if we swap K and B on S1, right? If that makes sense.
Right. So you just the idea
Yeah.
is to make them match.
Just to make them match. It doesn't really matter which one we match it to. Okay. So then kind of approaches I'm thinking of are kind of, we could loop through let's say string 1,
Okay.
or what I'm probably thinking is we could use pointers, right? So I have one pointer on index 1 on string 1 and one pointer on index 1 on string 2.
Okay.
And then if they don't match, then we could try to swap it somewhere, if that makes sense.
Swap what?
So we need to somehow make them equivalent. So
Okay.
essentially, right, the thought process is, right, we'll traverse both strings, get to
Yes.
one that doesn't match. So in this case, in string 1 and string 2, it's the first string, right?
Yeah. So
These two
here they
don't
don't
match.
match.
So now when we would continue to traverse either one, right? You could go S1 or S2, but I guess we could just go S2, right? So we would traverse S2 until we find the string that we're looking for, or the character that we're looking for, swap them, and then check if they're equivalent.
Yes, but what if it doesn't work if there's more than one? So let's use this example of so you're iterating S2 and comparing it to B, right?
Yes.
Okay. So
So I guess to kind of walk through,
yeah.
right? We would have 2 pointers, right? We'd have B, and then we'd have K, right? So on S1, right? And then on S2, right? So
Right.
we would first go B and K, right?
Okay.
These two do not match,
Okay.
right?
So what are you
So
gonna do with it?
so now we would say, in this case, it doesn't really matter which one we pick it on, right? But let's say, okay, we want to find a swap to make this a B on S2, right?
So
So we
you,
would
mhm.
continue to look through S2, A and B, and then we would then swap them, if that makes sense. So we
Okay.
would go B, or we would go, my bad, K, and then B. We would now check if these are equal. And if they're not, then we would return false. If that makes sense.
Yeah. So you
that means
have
there's, if they still aren't equal, right, then that means we need to make multiple swaps. And so we know that it's not a possibility, right, if we have to make multiple swaps.
So to summarize what you're saying,
Yeah,
is that you pick the first index of string S1, and then you pick the first index of S2, and then you're gonna literally iterate through S2 until you're gonna iterate both of them. Well, you're gonna iterate S2
yeah.
until
So I think
it doesn't find.
to clarify, right, like I'm going to iterate through both, right? So in the case of bank, it's the first one, right?
Okay.
But if we look at attack, right? Attack and defend, the second example, right? So we'd go A, and then on S2, we'd be at B, right?
So both, yeah, they're not equal.
So these aren't equal, right? So then we would keep going through
S2 until
S2 until we find an A. right? If we never find one, then we know for sure it's not true.
To return
Right.
false.
So we'd return false. But let's say we did find one. Let's say it was the band, right? We would swap them. Check if it's true. Check if they're now equal. And if they're not, then we know we would need to make more than one swap, if that makes sense.
Okay, and use example 3 as well.
Yeah. So on
Makes
example
sense.
3,
They're
we
the
would
same.
try to traverse both of them.
Yeah, so what
right?
happens here? The
So
same.
in this case, we would go K, those are equal. So we go on to the next one, both E, then both L, and those are fine, and then both B, and these are both fine. So we would just traverse them, if that makes sense.
Right.
Right. And then at the end, right, we have nothing to swap. So we check if these are equal, and then we now would come up with true, if that
So
makes
you
sense.
traverse S1, and as you traverse S, with each iteration of S1, you iterate through S2 until
So
they're
I'm
the same.
traversing through both until I find characters that aren't equal at the same index.
Yeah, but wouldn't the traversing S2 be nested inside of S1?
No. They'd be done sequentially, right? So I would first do them sequentially, right? Until I find what I'm looking for. I would do them sequentially until I find different characters, right? So I guess we could add our own little example, right? So if we did like pizza, right? And then if we did Potsy, if that makes sense, right?
Yeah.
So in this case, we need to make a swap on I and A, right? So in this case, we would first go P and then P, and those cases are the same, right? So then we would go I and A are not equal, right? So now we would then traverse
only
S2, right? Until we find the character that is equal to it. Then we would swap that index and then now check for equality on the entire string of S1, if that makes sense.
Right. Okay.
And so that's essentially what we do, right? Yeah.
Okay, so let's try to code it up.
So if I'll call this pointer 1 equal to 0, right? Into pointer 2 is equal to 0 as well, initially. So then we'll go while we'll just say like while P1 is less than S1 dot length. We essentially want to compare the two characters.
Okay.
So we want to take a look at this character. I'll call it C1. It's equal to S1 dot car at P1. And then this would essentially be the same thing, but for the character C2 of S2 at P2, right, at that second pointer.
Right.
Then we would check for equality, right? So we would say, so if P2, if C1 dot equals, I believe it is, but we can confirm that, C2, right? So if they are equal, then we want to increment and keep going forward, right?
Okay.
Right. If they're not equal, then we want to simply increment P2. Right.
Okay.
Now, in this case, right now, what I'm saying right now is that like with the code right here, we would just go B k, then we would only increment 2, right?
Yeah, so now we go
we
through the
need
loop again.
some way to know that we need to swap, essentially. So if we set a Boolean swap equals to false for now,
Okay,
and then I'll say I'll set swap equal to true. So if it equals true, that's fine. So in this case, so we'll set it to this case for now. I'm going to make this an else if though. Let's see, else if. And we'll set an if up here. So if swap equals true and C1 dot equals C2, right? So if that's the case, then we know that we need to swap, if that makes sense, right?
yeah,
So we know that we need to swap, then we essentially want to kind of more than likely build a new string. So I'm going to set string of how do you want to do this? We'll go we'll call it like string 2 equals s1 or s2. So here we essentially want to swap the characters at those indices, right? And so what we'll want to do is build a new string of s2 with those swapped.
okay,
So what we'll likely do is probably splice the strings. So I'm going to do s2. Well, I'll set 2 equal to st dot splice. And we want it up to confirm that that's how it's done. I believe it's from 0 up to P1, right? So that's from the first index up to the second, like the first pointer, like the character that we want to swap, right? Then we'll do plus the second character plus we want kind of everything else, if that makes sense. So we want probably the middle. So we want st dot splice p1 plus 1, right, up to p2, whatever position it is right now, plus s2 dot splice p2 plus 1. If that makes sense. I'm trying to make this a little smaller.
because when you do this with the first example, S2, so P1 should still be index of 0.
Yeah,
It should still be 0.
exactly.
And then you go, so you're getting that element, so you're getting that, so you're looking at S2, you're splicing S2, right? So you're getting that K. Right, so that that first part, S2 dot splice 0, comma P1, that gets the K, that gets the K, right? Is that what you're trying to do?
So I want to get everything, it's going to be a little funky for this case, right? The case that it's in the beginning. So I'll have to adjust for that because essentially what we'll be doing, I'm pretty sure that this, yeah, because this is essentially a splice from 0 to 0. So I'm not entirely sure if it will pick up K, if that makes sense. Right, like in the case of bank, or in this case, I want this to be empty.
So you want it to be, so that would be empty. And then what's
So I would
C2?
like this to be empty.
Okay,
C2 is now where B is at. So this should be a B,
okay,
right? Then this should be an A and N, right? From character 1 up to this character, but not including, right? So it should be an N. And
okay.
then this should be the character that we're looking for. Oh, actually, I think I'm missing a C1. Right, if that makes sense. So this should be the character that we, or actually, we want this to be. So in this case, this equals B, this equals B. So probably I'm missing, so I want S2 dot car app, and I want it at P1, if that makes sense, right? So I would like this to be empty. In the case of this bank, right? I want this to be empty, right? In the case that like we have a character that we're gonna swap like in the second position, this should be like the first character, right? So we can look at a case. So if we have like the case of like pizza, right? Pizza and pazza or pozzi. If we have that case, this should be the P in S2, if that makes sense. Because
So
the
it's
first swap would be
everything.
at A.
So this first part is everything before this
Everything
swap.
before the character we want to swap.
Okay,
This should be the character that we want in this new position. So there should be an I, right? Or it could even be like a C1, right? Because they're both the same character. But just for simplicity, right? So we could see it, like we're moving that like character in string 2 to a new position. So this should be an I in this case,
right,
right? That we're now moving here. So pizza becomes PI.
okay,
Then we want this to be the ZZ. So this should be ZZ. This should be the A, aka the character that was here. A, and then in the case that there's anything after that A, we would like it to be added here. We might run into some out of bounds errors, but we'll make those adjustments as needed.
okay.
Yeah.
Okay, so we do this when
So we do
have-
this when
yeah.
we know we need to swap a character and the two characters are equal, that like we've gotten to a character that equals this in this string.
Great. Okay,
Right.
so now we built this new string for it instead of S2.
Yeah. So
It becomes
little edge case, in the case that of like attack and defend, right? We also want to set, we also want to set E2 to be less than S2.
right, because if there's
Right.
never
Yeah,
a match.
yeah. Even though they're the same length, right?
Okay, so we have this new string. What do you want to do with it?
So now we have this new string, right? So from here, we'd want to break out of the
Okay.
while loop, and then we'll essentially check if this new string that we have equals the string 1, right? So if S1 dot equals the new string that we've built, right? Then it is possible with one swap. If it is not possible, or if they do not equal, then that means like there's no possible way to build it, or that we would need to do multiple swaps in that case, if that makes sense.
Okay. And then the case where it never hits this, if it never, this swap never gets changed
Yeah,
to
so
true.
in the case that like the swap never happens, right? We would simply just break it, like essentially we would just pass the length on P2, right?
Right.
We would pass the length on P2. And if that happens, we would just break out of this and we would essentially look at the string 1 and check if it equals
The
the
original two.
unchanged string 2, which it wouldn't. And thus, like we would also return false, if that makes sense.
Okay.
Right. Yeah, we are gonna have to do some adjustments on how we build this character though, because I do believe that in the case of bank or can, we do hit a just like out of bounds error, because this index
Yeah.
P2, which would be the last one, +1 just doesn't exist.
So
that
how
makes
can you
sense.
protect yourself from that out of bounds?
Yeah. I mean, it just depends on how the splice works.
Just if we look at this example and we go to that last part,
Yeah.
P2 should be 0, 1, 2, 3. No, it'll still be
So if we kind of walk through
two.
like the
Yeah.
first example, right? So P1 equals 0, P2 equals 0, right? So we would get those characters. So C1 would equal B, right? C1 would equal B, and C2 would equal K in the first
Yes.
case, right? So then we kind of don't hit this case yet.
Right.
They're not equal, right? And so we would then set swap equal to true, right? So that we know we need to swap, and then we would increment P2, right? So
Okay.
then on our next continuation, right, we're still at B, but this now equals A,
Yes.
right? These two are not equal again. So we increment again, and we still set it equal to true, right? So the same thing, N, we would increment again, set it equal to true. So now this equals B, right? So
Right.
in this case, right now swap equals true, and these two equal each other. So now we know we need to swap somehow, right? So then we would then build a version of 2 that looks like bank, right? It's kind of a rule,
Okay.
if that makes sense.
Great. Do you mind walking through your string builder method with this example?
Yeah. So I think I'm gonna make it a little easier on myself instead of doing splices. I'm probably just going to do, so I'll just do s2 dot split, right? And I'm gonna split it at index at just each individual character, right? So I'm going to make this an array of strings really quickly. And we'll just call it, for now, just ours. And
But
then
do you mind explaining the logic of this first before coding it out? Because it's
yeah. So essentially, I'm going to take the string of S2,
yes,
right? Split it into an
to an
array,
array.
so it's
Okay.
easier to manipulate.
And then
And then at the
swap.
end, so I'm going to swap them while it's an array, and then at the end, I'll join it all back together into a string.
Okay.
Check equality then, if that makes sense.
Yes.
Just so it's a little bit easier to manipulate, and so I'm not having to do any complex splicing with out of bounds errors or anything like that. So
Smooth.
if we look at cars at P1 at the first position, we want to make that equal to what the new character equals, if that makes sense. So C2, right?
Okay.
And then at the cars at where P2 equals, right? We want to make that S2 dot car at P1, if that makes sense. So what it equals here, what it equaled originally, which was a K, if that makes sense. So we're like swapping just the characters.
Okay. So in this case,
So in this case,
16,
the first one, so in this case,
P1 will be 0, right?
0, yeah. So P1 is 0,
So
right,
index is
still.
0. Mhm.
So a B, C2 is now a B on S2. So we would then make 0 on S2 a B, right? And then on the last index, right, which is what P2 should equal, we now make it whatever S2 equaled at the first position, which was a K,
Okay,
if that makes sense.
great. So now you have it as an array.
So now it's an array.
Swapped.
So now we'll swap it. So now we'll set it back equal to that join, and we want to join it with nothing. Right. So now this should essentially turn it back into a string, and then we'll break and then check equality,
Okay.
if that makes sense. Yeah. So I believe we might possibly run into an error because caret gives us characters and not strings. And we kind of are holding an array of strings. But I could, for now, I'm just going to run it. And if not, then I'll change it to a string in a second.
All right, wait, before you run it, delete the comment on lines 11 and 12.
Oh, yeah, thank you. Yeah, great. So if we try to run it now, expected a, oh, it's missing a semicolon. Kind of love it. So cannot find symbol S1 dot length. So these are strings. So we have to use the length method. So yeah, that's what I figured. So character cannot be converted to a type string. So I will just essentially wrap it in a kind of empty string, and that should clear that up. So method cannot find symbol dot join. So method join is string. Variable cars with type string. So it looks like it's stating that it will not, can't use the join method. So let's take a look. Maybe I am kind of.
Or maybe, how about you print out what is print what you have at chars?
Yeah, so we'll let's just and we'll print out what cars equals.
Yes. So it should have the array swapped.
Yeah, I think it might print out the hash, but hopefully there's a toString method and we can see it. So for now, I think we'll just. Well, I'm just going to set two. It's a S2 for now. Well, actually, I'll just leave it as that, and we can kind of break out of it. And it'll return false, but we can at least see what it equals. Yeah, so it returns this kind of hash. So there's no like it doesn't look like there's a toString on it, which is fine. So if we kind of guess for now, just to see what we got, we'll kind of loop through each string. So for each string, S in parse, kind of, yeah, you know. So like we'll quickly print just to see what everything equals. So bank, so cool. It is returning what we want.
Right.
So we just need to just make sure that this is getting converted into a string properly. So I initially thought cars.join would work. It might just need a car. No, empty character literal. I guess let's do a quick check on join. Or not, so we'll do W3 schools concatenate. I think that's better. We have strings, or actually we want to raise. And it's not helpful. So we'll just go back. Join. So we can take a look at that. This is for threads. I'm gonna look at the red join method. So this is a string array of how to do in Java. So it's string.join, and I need to pass
Takes
in the
two
array.
parameters. Yeah.
Cool. That's what I was missing. So if we do, it is 2 equals string dot join, and it is empty, and we want to pass in cars here.
Nice.
Now that should work. Cool. So that works for the case of bank. And then if we kind of take a look at it for every other case, hopefully how this runs. So this is an extremely long case.
The same, everything's the exact same, right? No, there's a small change.
So there's a small change. So in this case, there's GR at K and Q.
Okay.
So in this case,
you'll make a swap. You iterate until you hit K, right?
So we iterate until we hit K and Q on the top version, around S1, let's say, right? Then we iterate here until we hit this next K, which is over here. And then we make a swap.
So there's have to be a case for duplicate case. Yeah.
Yeah, so it looks like the reason for this is because we're looking for the first K, in which like just this K is equal to this K, and we swap. But there's actually nothing wrong here. So we should actually be looking for K at the index, which is this K, where these two are also not equal.
Yeah, so the indexes are also not the same.
Yeah.
Good point.
So we can actually make that change pretty quickly. So if swap equals that, right? And C1 equals CQ. And so we can add another and, right? C. So in this case, we might want to check if that character on B is the same, on S1 is the same, if that makes sense, right?
Yes.
So we might want to do S1 dot car at S1 dot car at P2
Okay.
dot equals S2 dot car at, and we want to look at the car at E1, if that makes sense, right? So in this case, we're checking if we need to make a swap, so that's true. We're making sure that the character that we're looking for is equal to the character in the beginning, right? So that this K is equal to AK, right? That like
Yeah.
the pointer at 2 is equal to the K, the character we want to swap, right? So that's good. But then we're also checking that this character here is equal to this character, if that makes sense. Right?
Yes.
Because it's essentially
It's
I
equal
should be able to
to,
swap this K or this Q to here, and now they should be equal, right? So, and that's the case at this K over here, right? Where the K that we're going to swap at that position on S1, it equals the Q we want to swap as well.
one more time. So
Yeah,
let me,
so
so if you don't mind, let me phrase my understanding of what you're saying. So we swap through S1 and look through, move your mouse until we get to that K.
yeah, so
Yeah.
we go here on both of them.
K. So
Right?
this is
K
where
does
it's a
not equal Q.
So we iterate through the
So we
S2.
So we leave our P1 here.
Yeah.
We iterate through S2 until we find a K. Right, cool. We have a K right
Okay.
here, right? And we do need to swap. So this
And
K
then, yeah.
equals this K, right? So that's good. They're both K, right? But this character here does not equal this character, right? So it's not like an equivalent swap. So we're swapping what did equal what was a Q and a K, right?
Okay.
We're swapping that. We're making this equivalent here, but we're making this not equivalent.
So
if that
that
makes sense.
in your lines 14, the S1 dot char at P2,
Yeah, so
that has to be
what-
Q.
Yeah, so what we do to confirm that is just make sure that this character that we're swapping, since we're going to swap this K at this position, we also want to make sure that like the swap will actually fix the problem, if that makes sense.
Yes. Okay, let's give that a try.
If we try to run it now, cannot be dereferenced, so I likely have to save them. So S1 at car at P2. So if we set this equal to character, so we'll say it like we'll call it like I'll just call it so this is S1 at P2, right? Equals this, and then we'll call this do something similar. We'll just call this S2 underscore P1 equals this, right? And so now we'll instead just look at S1 underscore 2 if it equals S2 underscore P1. Okay. And that should be okay. And then if we run it, should also fix this problem. Wrong answer again. So what case are we running into now, right? This is the same test case. So if we take a look, I'm returning false because they're not equivalent when it is expected to be true, right? And we saw that because we should be able to swap this Q and this K, like they should be able to swap. This is the position we're looking to swap with, right? So
Right.
if we take a look, if we take a look, right, we essentially kind of traverse, right? So we'll go SS, we'll go, these are all equal, so we'll keep traversing until we get to here, Q and K and Q, right? So then we will set swap equal to true, and we'll only increment P2, right? So then we'll keep going to here, through all of this until we get to our first K, right? And then once we get to our first K, swap now equals true. P1s is still a K, right? And they're equal, cool. So now we hit this case. But now if we take a look at S1 at this position, which is a K, we want to check if that is equal to S2 at P1, which it shouldn't. So it should equal a Q, right? So we kind of skip this edge case, if that makes sense. So we skip that case. So if we keep going forward, well, we hit another K, the next K, which is here. And then we will kind of, it will be true. So swap will be true. This K equals the original pointer. This K, the Ks will be equal, and S1 at this position will equal S2 back at P1, if that makes sense.
So why don't you print inside of this
Yeah, so we can
to-
print.
if it's getting the indexes you want?
Yeah, so let's do system line. And I think I'll print what the cars equal, if that makes sense. So we'll do C1. Yeah. I'm just going to leave it's changes. I'll just do C1 plus that plus 2 plus, and then this is S1 underscore 2, and then plus S2 underscore P1. And that should get printed out for each line.
And you have to change the test case.
Yeah, so this looks good.
So you can copy that test case.
Yep.
That input. So it's going to
So
be
if
a
we
big console.
run it, yeah, it's going to be a huge console. So if we take a look at it, YYY SSS, that's good. So we go up until we get,
We hit the Q, right?
so here until this is the case in which we hit the KQ, right? KQ right here. So really, I think it's beneficial if we look at mainly this right here, right? So in this case, we hit the KQ, right?
Right.
And we continue to go and we look for the ones where Z is until we get a K. So when we get our first K, here. Ooh. Wait a minute. So at some point here. Okay, so at this case, right, at the KQ, right, which is exactly what we want, right? So in this is the case where P1, aka the original position, is equal to a K. We have
Yes.
found a K in the string, right? We found a K in the string. Then we know that the original spot equals a K, if that makes sense. And then, my bad. So this is the case where we get to this K right here, right? So we found our first K, right? We found our first K.
Yeah.
So swap equals true. This does equal a K, but S1 at this new position equals a K, and
Right. It should be
S2 and S2 at the original position equals a Q. So
so
these are not the same.
yeah,
So
we need it to be KKQQ.
we need it to be KKQQ, right?
Okay.
So that's not
But
true. And then
but it's
for
still
some
iterating.
reason, we iterate on P.
So look at your else if.
Okay. So at this else if, right?
You need another condition here.
Yeah, so I need some other condition here to kind of prevent this, right? So okay. So I would need some condition where like just these two are equal to each other. Or I want it to skip this condition, if that makes sense. So if C2 equals and not swap, that makes sense. And that should resolve this case, right? So if they're equivalent, but so if they're equivalent, but we want to swap, but they are not true, right? Then we just want to keep going, right? If that makes sense.
Yeah. So for your example, you have KKKQ.
So we have
and
KKKQ, right? So KKKQ doesn't hit this edge case, right? So, but since K still equals K, it hit this edge case and it incremented P1, right? Which
Yeah.
is what we don't want it to do. We only want to skip this case. We only want to hit this case if they're equal. And
It's like the first
we
time.
don't want to swap it only for the first case, right?
Yeah.
Exactly.
Okay. Let's test
So
out.
we'll test this out. And that should kind of fix that case. Cool. So if we submit now, this should work. Cool. Yeah.
Awesome. Why don't summarize? You mind summarizing what you did? If you see any things improvements, we can talk about it. If not,
Yeah.
we can just talk about the complexities.
Yeah. I mean, so well, let me remove this.
Oh yeah, that's probably why I slowed
Print
down.
line. So the time is very bad. So if we submit again, it should be a little bit quicker. Yeah. So yeah, I mean, if we take a look at this, right? Our time complexity isn't too bad, right? So we're traversing in the worst case, we traverse both, right? So we're kind of hitting O of n plus n m time, where n is string 1 and m is string 2, right? And that's in the case that like we both are equivalent, so we just keep going all the way to the end. Right, so that's that case, or that like we somehow need to swap at the end or something like that. And it's not possible, or something of that nature, right?
So you're
Um,
traversing so that both S1 and S2, and then in your swap condition here, does that take any time complexity?
Not so much time as it is taking up space, right? So kind of the space complexity, right? We're having to build an array that could be n, or it really could be n long because they're the same length, right?
Yeah, so it doesn't matter which one.
Yeah, it doesn't really matter which one.
Okay.
And I mean, like, so we're kind of building that array, and then we're having to swap characters, which are kind of instantaneous, right? Because we're looking at indexes.
Yes.
So it's kind of O of one time. And then we're kind of having to rejoin and rebuild a new string, which would kind of be O of n, if that makes sense, right? Because I do believe join has you traverse the entire string and build a new string, or the entire array and build a new string.
Okay, so
that makes sense.
O of n for both time and space.
Yeah, sadly.
Okay, because I know we did a lot. So would you mind summarizing this algorithm?
Yeah, so essentially what the algorithm is doing is essentially we are traversing both strings kind of at the
Yes.
same index, right? And then once we reach an index where the two characters aren't equal, we'll continue on one of them until we find a character worthy of a swap,
Okay.
right? Which means that the character is equal to what is the character we're looking for, and also that swapping it there would make them equivalent, at least at that position, if that makes sense.
Yes.
Right? So kind of the logic flows is that we'll go up to here. These two aren't equivalent, at least as of now, right? So we'll keep traversing until we find a character we're looking for. And then we know what character should equal at this new position, like what we're going to swap it for. So if that doesn't equal it on the other character, on the other string, then we know we need to keep looking until we
Okay.
find one that will make them equivalent. And so in this case, it's this one, right? So this would make them equivalent. And then once we just perform one swap, we can check equivalency because we're only looking for at most one swap, right? So if they still aren't equivalent, that means that we would have to do some swap over here, which we're not allowed to do
Right,
by
and we just
nature of the
return false.
question.
Mhm.
And so we would just return false, right? If that makes sense.
Awesome, amazing job. I know this one was kind of difficult, but you're able to figure it out.
Yeah, cool.